Let us consider this problem of constructing a D chart. See, the sample sizes are different for each of the lot, right? So this is D chart for varying sample size. See, the lot number, n values and d values are given. Number of defectives are given. Now we are supposed to compute the p values. P is equal to d by n, right? So 40 divided by 4000, you get 0.01. 30 divided by 3000, 0.01. 15 divided by 1500, 10 divided by 2000, 10 divided by 1000, 40 divided by 2000, you get 0.02, 30 divided by 3000, 30 divided by 3000, 20 divided by 4000, 20 divided by 3500. Okay. Now you add all these values. Right. And calculate the average, which is P bar. Average values of P is P bar. You get 0.0096. And you also compute P bar into 1 minus P bar. Okay. 0.0096 into 1 minus 0.0096. You get 0.0095. Okay. With this idea, you have P bar. So you compute n into P bar 0.0096 into n for 4000 into 0.0096. You get 38.4. 3000 into 0.0096. You get 28.8, and 1500 into 0.0096. You get 14.4. 2000 into 0.0096, you get 19.2. 9.6. 2000 into 0.0096, 3000 into 0.0096, 3000 into 0.0096, 4000 into 0.0096, 3500 into 0.0096. Compute this. Okay. Now let us compute np bar into 1 minus p bar. Take square root and multiply by 3. For which p bar into 1 minus p bar has been computed already. 0.0095 into n is 4000. Right. Multiply. Then take square root and then multiply by 3. Let us write the answer. It is 18.49. Okay. Now point not 0095 into 3000, take square root, multiply by 3 and take down the answer 16.02. Okay. 1500 into 0.0095, take square root and multiply by 3. You get 11.32. Right. And now it is 2000 into 0.0095, take square root and multiply by 3. You get 13.08. Then here 9.25. For 2000 it is 13.08. For 3000 we have already computed. We can just write the values. And for 4000 it is 18.49. right? And for 3500 into 0.0095 equal to, take square root and multiply by 3. You get 17.30. Now, this NP bar minus this value gives the lower control limit, and when you add you get the upper control limit. Okay, 38.4 minus 18.49, you get 19.91. 28.8 minus 16.02, you get 12.78. 14.4 minus 11.32, you get 3.08. 19.2 minus 13.08, you get 6.12. 9.6 minus 9.25, you get 0.35. 19.2 minus 13.08, 6.12. 28.8 minus 16.02, 12.78. 12.78. 38.4 minus 18.49, 19.91. 33.6 minus 17.30, it is 16.30. Now this NP bar plus 3 into square root of NP bar into 1 minus P bar gives the upper control limit. 38.4 plus 18.49, 56.89. 16.02 plus 12.78, 28.80. 11.32 plus 3.08, it is 14.40. 13.08, sorry 28.8 plus 16.02, 44.82. Here 14.4 plus 11.32, 25.72. 19.2 NP bar plus 13.08, it is 32.28. Then 9.6 plus 9.25, it is 18.85. 19.2 plus 13.08, 32.28. 28.2 plus 16.02, 44.82. 28.8 plus 16.02, 44.82. 38.4 plus 18.49, 56.89. 33.6 plus 17.30, 50.90. Right? So we have calculated the UCL and LCL values. Let us come to D chart. In D chart, we are going to plot the D values on the y-axis. Right? Now let us have a look at the range of D values. The least value was 10 and the highest value was 40. And coming to the upper control limit, you have 56 as the highest value, and for lower control limit it is 0.35. So let me take a scale like this. 10 units. Okay, 10 units will do for me. First, let me plot the number of lots. The number of lots is 10. So let me go for a scale like this. This is lot number. Right? And for the first sample, let me first consider the LCL values here. LCL values 19.9, 19.9, it is 20. When it is rounded, it is 20. and 12.78, it is rounded to 13. 3.08 is rounded to 3. 6.12 is rounded to 6. And it is 0.35 is rounded to 0. 6.12 once again is rounded to 6. 12.78 is rounded to 13. Once again 12.18. Sorry, 78. 19.9 is rounded to 20. 16.3 is rounded to 16. Okay, so these are the lower control limits. Let me join the lower control limits by means of dotted lines, split lines, straight lines, right? This is the lower control limit. Let us now come to the upper control limit. See, 56.89 is rounded to 57. 44.82 is rounded to 45. 25.72 is rounded to 26. Then it is 32.28 is rounded to 32. 18.85 is rounded to 19. 32.28 once again. 44.82 is rounded to 45. Once again 45. 56.89 is rounded to 57. 50.9 is rounded to 51. Fine. So let us join these points. This is your UCL. Okay. Now let us plot the D values. The first value is 40. The second value, D values I am plotting, right? 40. Then it is 30. The third one is 15. 15 here. Fourth one is 10. 10 here. Fifth one is also 10. Then it is 40. 40. Then it is 30. And once again it is 30. Then it is 20. The same value. Then it is 20. Right? So, one point is falling beyond the control limit. So, the process is not in control. See, 1 point on the chart falls beyond the control limit. So, the process is not in control. Right? Let us write the scale. X-axis 1 centimeter equal to 1 lot or 1 unit. Y-axis 1 centimeter equal to 10 units. Right? So this is the way you construct the control chart for the number of defectives with varying sample size. Okay, thank you.